everyone. I am Assistant Professor Urmi Shah from IT/ICT Department of LG Institute of Engineering and Technology. In today's session, we will be starting with the introduction to radio communication. What are radio transmitters? What are radio receivers? That we will be discussing in our fifth unit, which we started in our previous session. So let's continue today. What are the receiver section blocks and what are the types of receiver used in radio communication field? So let's start with this session. So basically in this session we are going to cover is this following topic, that is different types of transmitters and receivers. Then we will be using the wireless technologies which are involved in our radio communication field. Then we will be seeing the mobile cell phone, which are the application of radio communication. Then we will be looking forward to the further applications, that is television, radar and Wi-Fi. So now let's start understanding what are the following topics where our radio communication concept is used for transmission and reception purpose. So let's start understanding about the basic circuitry of radio communication block. So basically the different types of transmitter and receiver block which are involved in radio communication unit or in radio communication section are the radio frequency chain. Now what does this RF chain does? It converts the signal which is given as an input signal or message signal in form of RF signal. And when there are multiple input signal or multiple message signal, at that time it is going to convert those input signal into radio frequency chain. These RF chain is going to be further processed by the antenna for transmitting purpose, and it is going to be used by the receiver side for reception, and further the coding or the decoding of this RF chain will be done at the receiver side. Secondly, we have the modulation chain. Now why we are performing modulation? Whenever we have a long distance communication, at that time we are going towards the modulation part of any signal. We are converting our message signal by multiplying it with a carrier signal to make it modulated form such that it can be transmitted over longer distances with shorter antenna heights. This way we perform the modulation for multiple input or message signal and transmit them as a chain form that we call modulation chain. Another block is the TRF receiver. TRF is nothing but the tuned radio frequency receiver. Then we have the super heterodyne receiver. These are the two receivers which are used currently in industry and markets for reception purpose. So we will be looking forward to these receivers in the upcoming slide. Now, we all are wondering that these are the different types of transmitter and receiver. Now let's understand what is TRF and what is super heterodyne receiver. Basically, this is the block diagram of TRF receiver. As you can see, the TRF receiver will have an antenna block from where it will be reproducing or receiving the transmitted signal. From antenna it will pass the signal to RF amplifier 1, that is the first radio frequency amplifier. Further it will process the signal and will transmit it to the radio frequency amplifier 2. So this way it is passing the input or the transmitted signal to multiple radio frequency amplifiers. So this we call as RF chain. Multiple times it will be processed by passing the transmitted signal to radio frequency amplifier. Then it will be passed on to the demodulator block, that is our detector block, and further from the detector block it will be processed to the audio frequency amplifier, that is our AF amplification unit. Further we have two AF amplifier circuitry, and at the end it will be transmitted to the receiver block, that is our sound signal. That is our speaker. It will be producing the sound signal which was originally transmitted. So you can see over here, initially it was highly modulated, then we pass on to the RF amplifier, so it is slightly amplified, then we further again pass it on to the RF amplifier, so it is more amplified. After passing it to the demodulator part, it is retrieved in form of message signal and it is further amplified. So this is our original signal which is passed on by the TRF receiver. So this way the TRF receiver works. Now further, let's understand what is super heterodyne receiver. Where super heterodyne receiver is used and how it is different from the TRF receiver. Basically, super heterodyne receiver will have an antenna block. From antenna block, the received signal will be passed on to RF amplifier, then it will be passed on to the frequency meter, then frequency meter is going to generate the local oscillator circuitry. Here, the RF amplifier is going to process the signal further into the frequency meter, where it will be going to be added up with the local oscillator signal, and further it will be processed by the IF amplifier. Now what is IF amplifier? IF amplifier is intermediate amplifier. Intermediate amplifier will process it to the detector block, and that detector block will be processed to the voltage amplifier. And at the end, we have our speaker block. So at speaker block, we will have our receive or reception signal. So this is how the super heterodyne receiver block works. In this way, we will have the reception of signal using super heterodyne receiver circuitry. Now let's move ahead with the amplitude modulation signal. Basically, we have three types of amplitude modulation signal. That is RF carrier wave. As you can see, the first signal is the radio frequency carrier wave signal. Then we have the AF modulating signal, that is nothing but the audio frequency modulating signal. Then we have is the RF amplitude modulated carrier wave signal. Here you can see these are the different versions of modulated signal which are involved in transmission and reception of any signal. Further, you can see these are the different components of a radio receiver. Basically, a radio receiver has following blocks, and this is how the front view of radio receiver looks. Moving ahead, what are the applications of our radio wave communication? So first application is it is used in wireless technologies. We use wireless technologies in our everyday life, and we use them as well as we use their purpose and benefit for our use, which are related to radio waves. From internet to mobile phones, we regularly depend on wireless connectivity. This is a very basic need in nowadays. We use radio waves for opening garage doors, car doors. Then we require wireless keys to open them. Also we use radio waves which are implemented using the Bluetooth technology. We use the live news report technology. We use internet during flights. So all these things has been the basic requirement in our day-to-day life right now in the current technology era, which is dependent on the application or the usage of radio waves. Further, the next example is mobile and cellular phones. Mobile phones have become one of the most used technological devices In the last decades, and with the use or with the aid of radio communication waves, it has been possible that they are being used from one device to many more devices. Just like regular cordless phone, mobile phones are the radio that transmit the receivers. Radio waves carry these phone signals which are allowed to transmit text messages, phone calls from one section to other section, from one person to another person or to designated receivers. Not only do radio waves provide us with those many things, but they also provide us with internet connectivity with 3G, 4G and upcoming 5G technology will be there. So all these are having the usage or aid of radio communication waves. Further, the next application is television. Television has been one of the most important media in the last several decades. Its impact on the way we use this media as a whole has become more usual since it was invented. Radio waves carry the television signal and transmit them further as radio waves have larger wavelength. This allows television to be broadcasted through satellite as radio waves can pass through the atmosphere. So these are another application of radio wave communication. Next application is in radar. Radar uses radio waves to detect an object's direction, distance and speed, and using it travels. Radar has been considerably used in seawater or in recent war or military attacks. In modern use, it has been used in the battlefield for exploration or for military surveillance or for ocean surveillance and as well in marine radars. Radar is also used for weather forecasting or weather monitoring. So this is again having an application of radio waves. Now radio waves in space. Radio astronomy is the study of what happens among celestial objects such as stars, planets, our whole planetary section involving galaxies. Radio waves are detected using large radio antenna to produce the images that can't be seen through our regular telescopes. So these are the application of radio waves and recent scientists are working on all these applications and areas for exploring more and more research in this field. Again, Wi-Fi, a most important and prior requirement for any human being in today's life. Wi-Fi, which follows one of the key characteristics of radio waves. Nowadays on railway stations also we have Wi-Fi connectivity. No place is left where there won't be any Wi-Fi connection. Everywhere we have Wi-Fi connectivity, which is leading the users to have the ability to interact with a variety of medias. And radio waves are again involved in this, which are transmitted and received in the same way, just like walkie-talkie, two-way radio. So these are all applications of radio waves. Wi-Fi, which is the most important and prior application in today's era. Following are the references which I have referred for this topics which we have discussed in today's session. In the upcoming session, we will be moving ahead with the further topics of radio transmitter and receiver section. Thank you so much for watching this video. Thank you. So we are learning introduction to radio communication, what is radio transmitter, what is radio receiver. Have you all understand the following applications? Like these applications are known to us. We are using in our day-to-day life. That is television, radar, radio waves, Wi-Fi, mobile phones, telecommunication, then wireless technologies. All these things are revolving around us, right? We are using it in our day-to-day life. But have you imagined that what are the kind of waves or what are the kind of signals involved in communication process of such application. So yes, here comes the use of radio waves. Radio itself means it is traveling in air. It is traveling in free space. There is no boundary for such communication. So all this application evolve the use of radio waves. So here comes the most important application, and further more research is going on for more applications in the field of radio communication, antenna communication, wave propagation, electromagnetic spectrum theory. Right now we are developing 5G technology, 6G, 7G we are working upon in US, in UK and in India as well. Research is going on for further advancement in the speed of wireless connectivity. Right now, Jio is also investing a lot of money or market in this technologies, and we will be having a more digitization whenever we are going in the technology era improvement. As we will be moving towards digitization, there will be the usage of radio waves. So these are the application of radio communication which will be used in our future life. Okay.